Okay, guys. So the first conic section that we're studying is the circle. So the circle is where we take that double cone and we slice it with a plane that is parallel to one of the bases of the cone. Now, the definition of a circle is the set of all points in a plane that are a given distance r from a fixed point called the center. I think that definition or something very similar is on your note sheet. Is it? Yes? Okay. All right, so let's see how we develop the formula for the circle. It is already on your note sheet, but let's take a look at this. Does everybody recognize this formula? Yes. This is the distance formula, isn't it? The distance is the square root of the difference in our x's squared plus the difference in our y squared. Well, what is the distance between the center and any point on this circle? Isn't it the same?
Yes.
What do we call all those distances?
Radius.
The radius. We call them r. All right, so here I could say r is equal to, because that's what the distance is between the center and any point on the radius. Now,
5.
when we studied functions, what did we call the center or the vertex or the inflection point? What did we call them? We called them h and k. Yeah. So, do you see how this kind of naturally flows from what we've already studied? We know about distance. We know that when we had the vertex or an inflection point or a starting point for our other functions, we called it hk. Now, to undo this square root, what would we do to both sides? Square them. Do you see now we have the formula that matches what's on our formula sheet?
Why, yes.
Okay, so this is the form that we will write circles in. Okay, so that's what we're hoping for. We're hoping for x minus the x value at the vertex squared plus y minus the y value at the vertex.
And the vertex is just the center.
Not the vertex. I'm sorry. I should be saying center. Thank you. It is not called a vertex. It is the center. Is equal to the radius squared. So let's take a look at this. I already have a graph here. Where is the center?
0, 0. Oh, that line crossing. Oh, okay.
If we consider this our axis. There we go. Our center is 2, 1. So if we, let me just go ahead and spell these out real quickly. Our center is hk, our radius is r. So our center for this one is 2, 1.
-1.
Thank you, -1. And what is the length of the radius?
5.
5. So the equation for this one would be x minus
2
squared plus
x plus 1
y plus 1 squared is equal to the radius squared, 25.
I have a question.
Yes.
Okay, if you're doing a sphere, it's anything except you add a z minus whatever.
Yes.
Okay. But then if it's hk, then what's the other? It doesn't matter. Yeah, I guess you're right.
They call it something different on the circle.
Okay.
All right. Now, let's say we have this equation. X minus 5 squared plus y squared equals 1. Okay? Let's try to make a sketch of this. So first, tell me where the center is. Where would the center be of this circle?
0, 3.
The center would be at
5, 0.
5, 0. Let's see again. I'll drag this over. Okay, and what would the length of the radius be?
1.
1, because the square root of 1 is 1. All right, so if we were to graph this, I would need to go over to 5, 0, and put my center. So we're going to start with the center. Now, the radius is 1 unit. So what I do is I add 1 unit to my y value. So go up 1, subtract 1 unit to my y value. Go down 1. Add 1 to my x value, subtract 1 to my x value. So now I have 4 points that are 1 unit away from my center. And to the best of my ability, which is, as you'll see in just a moment, not good, but to the best of my ability, I will draw a circle.
That was
it was so good until it got the hump.
so good.
That was
The tool would work if I had and made the thing accurate, but it's hard. The tool doesn't, the tool's tricky.
I have a question.
And I'm really good with the Mobi, if I, have to say so myself. It's tricky. I made the wrong thing red. Is there a no color option? We'll go there. It's hard to get the circle exactly where you want it when
Do you have to put it on the center or like the top?
It's hard. It's just hard.
Can you keep writing in red?
The red's better?
Yeah, it's
Okay.
Like sharp.
Hard to see the blue on the grid. Okay. Now, let's say we had a center at 0, -3, and our radius is 12. What would the equation be, guys?
X squared plus
Good.
Is equal to 144.
Equals 144. Beautiful. All right, we're not going to graph that one because I gave you a huge radius, but that's how we would do it. All right. So basically, the two things we need to write the equation for a circle are the center and the radius. But what if we were just given the center and a point? Okay, so we know the center is 3, 7. So we can get that part. Now, how can I find the radius? Distance formula. But where does this come from? Where did this form come from? The distance formula. So if I just plug this in, do you see this is the distance formula? So if I plug in the 7 and I plug in the 10, I am actually solving for r squared, which is what I want. So what is 4 squared? 16. What is 3 squared?
9.
9. What is 16 plus 9?
25.
25. So all I have to do is go back up there where I had the r squared and sub back in what r squared equals, and this is my equation. Any questions? All right. We have done circles before. Is it all feeling somewhat familiar? We did some circles last semester, so some of this should be familiar. If the endpoints of the diameter are -6,3 and 2,3, find the equation for the circle. So, the two things I need, center and radius. Do I have either of those?
No.
No. How can I find the center?
Find the midpoint.
Midpoint. Good. So, the midpoint is the center. So what would the center of a circle whose endpoints of the diameter are -6,3 and 2,3, what would it be?
Or negative. Oh, you're right.
-2, 3.
3.
Okay? So we get that the center is the point -2, 3. So we go ahead and set up the equation. So we'd say, what is it? X plus 2 squared. Y minus 3 squared equals what? How do I figure it out? Pick a point and plug it in. So tell me what you get. 16. Okay, and we can get that by plugging in either point. 2 plus 2 squared plus 3 minus 3 squared is 4 squared plus 0 is 16. Okay, guys, let's take a look at our graphic organizer for our conics. So, we developed the form. We know that this is our center, this is our radius. What did we decide? How do we represent the center?
HK.
HK, as an order pair, it would be HK. How do we represent the radius?
R.
R. Now, how do I find the 4 points?
H
Here,
H plus R, K minus R, K plus R.
very, that's what I do. To find the 4 points, I take my H and I add and subtract R to it. That gives me the left and right. This would be the H minus the R. This would be the H plus the R. Does that make sense? And then the other two would be k plus or minus r. This would be the k plus r. This would be the k minus r. All right, right now we're just going to be focusing on two different types of sections, the circle and the parabola. But pretty soon we'll have all four of them mixed up all together. So if we're just looking at the equations, what do you see here? Do you notice that the x is being squared and the y is squared? So we should notice that both x and y are squared. What would the understood leading coefficient be here? 1. What would the understood leading coefficient be there? 1. So do you see that the leading coefficients are equal? The leading coefficient?
Can you say coefficient again?
No. Coefficient?
Just gotta watch the video on YouTube.
Oh yeah.
I may not post this one if y'all are good.
No, please. It's adorable.
I will not say the word water for you today.
Is that it?
Yeah, but y'all
But
are
she
going to
didn't
make
say it
fun
the
of
right
me. I
way.
know. All right, and the last thing that we should notice that identifies this as a circle is that it is a sum. It's the x squares plus the y squares. So those are the things we should look for to tell if we have a circle. And then if we do, we just put it in this form and we're good.
So the leading coefficients have to be the same. All those things have to be like
Yes.
checklist in order to work.
Exactly.
Are any of these the same
Exactly.
for other things? Any of these three specific characteristics?
Okay, the both variables being squared is also true for the ellipse and the hyperbola. It is not true for the parabola, which you already knew. But one of these will be different. Or both of those will be different, and we'll look at them when we get there. All right, I meant to have this covered up, but to get this in the right form, do you guys remember how to complete the square?
No.
All right, so let's talk through the steps. How do I know this is a circle? Well, first of all, it's an x squared and a y squared. Both my variables are squared. Check. Okay, are the leading coefficients the same?
Yes.
Understood 1, understood 1. Check. And when we get it in the correct form, it'll always be 1. That understood 1. Is it an x squared plus a y squared? Is it a sum? Check. So I know it's a circle. Even though it's not in the right form, I know what it is. Okay, so to get in the right form, the first thing we're going to do are group our x's and group our y's and move the constant to the other side. So in this first step, our x's were already together. That was nice. Our y's were already together. Also nice. And our constant was already on the other side. Check. Now, step 2 in completing the square, and we have done this, you did this a good bit last year, is we take half the middle term. What is half of 2? 1, and square it. What is 1 squared? 1. So I'm going to add 1 here and to this side. I cannot introduce a new number to an equation without adding it to both sides. Okay? What is half of negative 6? Negative 3. I square that. What do I get? 9. So whatever I add to one side of equation, I introduced a new number, I must also do to the other. All right. Now, after we do that, then we rewrite as the binomial squares. So basically, we're factoring this trinomial into a binomial squared. We're factoring this one into a binomial squared. And then we add this all up.
4.
So, 4. So now we're in the right form. We have x plus 1 squared plus y minus 3 squared equals 4. Now it's easy to graph. Where's the center? Negative 1, 3. What is the length of the radius? 2. All right, any questions? All right, you try.
Try.
Alright, I got this.
Good. Alright, are we ready?
Are you wearing a microphone?
Did you get x plus 2 squared? I am wearing a microphone. Plus y minus 4 squared equals 9. Where is the center? Negative 2, 4. What is the length of the radius? 3. Would you be able to graph it easily knowing those two pieces of information? Great. Okay. Alright, now let's back and we're going to review the parabola. Now before we do that, there is a video an animation I would like to show you about the parabola.
Is this as cool as the other one?
This is cool. So, oops, I should have at least gone over the definition. A parabola is the set of all points in a plane that are equidistant from a fixed point called the focus. Here, this would be the focus, and a line that is called the directrix. Okay, now when we graphed parabolas last year, we didn't graph them by their geometric definition, which is this. All we graphed by last year were, we used find the vertex and then apply the moves. That's what we did. Well, this year we're going to look at it from the geometric definition, which tells us it's a set of all points in a plane that are equidistant from a fixed point, the focus, and a line called the directrix. So, let's take a look and see how it is formed.
Is this another animation?
Yeah. Hold on.
Says if it does not appear, click here.
I know what it says. I think I've just somehow stopped it. Okay, we'll go back and do it the long way. Tracing the parabola. Here. I just left it up too long.
It's his fault.
I know, it worked fine last period.
Shit.
Oh, that's cool. We didn't want to see it.
Bummer.
You demonstrated for us.
No, my demonstration is not near as interesting as this one. Well, huh? It really isn't working. Okay, I'm going to try one more time, and if this doesn't work, then I'm going to give and just show you.
It says if it doesn't appear, click here.
I did, but that sent me to another dark page.
I left your paper eraser.
It's not on here.
It's gonna be his long rails.
Bummer. 'Cause this is a really good one.
Is it better than the last one?
It's just as good as the last one.
It's not.
Is that how it's done?
Okay, sometimes it'll work when I open it up in a different. Let's try Mozilla, and then we'll give up. Huh?
I'll be basic schooling.
I'll have to.
That's what Oaks do in this research paper.
Good times, good times.
Thomas.
The connection has a time.
Plurality.
I don't understand.
My race just
Look and stop. Let's just stop that.
Alright, it looks like it's down. I'll have to show you another day. It's a real bummer. But what it does is, it shows you, and I'm just going to do it on the board real quickly here. Sorry, Hayes. What it shows you is, if this distance, I didn't draw that well, and the distance to here is always congruent. The distance from the focus to the parabola and the parabola to the directrix is always congruent. So, focus to parabola, parabola always congruent. And there's this drawing, very nice. And what it does is an animation showing you all the way around that those match up. So that's the definition. See, you can't stare at my drawing forever like you can the cool animation. Maybe I'll give it a shot one more
I'm kind of
time.
confused now.
So that distance is congruent. So this is our vertex form that we studied. Y equals a times x minus h squared plus k. And we know where the vertex is. We know the vertex is the point, what? HK. And when we graphed it previously, we did it by moves. And you may still do it that way. But here's a new way to do it. And sometimes this way is actually easier. So let's look at the equation. Y equals 1/8 x minus 2 squared plus 1. Where would the vertex be, guys?
2, 1.
The vertex is the point 2, 1. Now, when we go to graph it, first thing we're going to do is sketch a little axis here. And then we can go plot our point at 2, 1. Alright, now this is 1/8. And do you see here that A is equal to 1 over 4p? Or if I solve this for p, it would be p equal to 1 over 4a. Either way.
These two.
Okay, so what would p be here? So in this case, we can either say 1/8 equals 1 over 4p, or we could say p equals 1 over 4. Alright, so we should see p equals 2. And you can do it whichever way, but p is 2. means is the distance here, this is our P. This, in our case, would be 2. So the focus is up 2 units, and the directrix is down 2 units. Now, I know because it's positive, it's going to be opening up, and the focus is always inside our parabola. All right, so what we're going to do is now we're going to draw in the directrix. So this is my horizontal line from our directrix. Now, let's go back and look at this. This is a different parabola, but it is drawn to scale here. This is 1 and 1. So if this is considered P, what is this distance?
Q.
2P. What is this distance? 2P. So from our focus, do you see we can just double P to get a point on the graph? Okay, so I could go out, our P is what? 2, so I double that, I go out 1, 2, 3, 4 on this side, and this is where I kind of made myself. I go out 1, 2, 3, 4 on this side. Oops. I did it from the wrong spot. You have to do it from the focus. From the focus. Whoopsie. And then this is our graph.
Why did we go out 2 more? Like, how do we find the directory again? Directory.
It's in the drawer. In the desk. Oh.
How did we find what now?
Directrix.
We all help me find the hand on here. Can I see the hand?
Oh.
Wait, and somebody open the door too, please.
I don't see it. I don't see it. Is it like a finger?
It's at the
It's
very
at the
bottom.
very bottom.
Jacob's got 104 fever, and I gotta check him out and head.
Okay, okay.
Where's Scotty?
It'll be on the video if you need it. You may be fine.
Have fun, Scotty. Shout
Very
out to
bottom.
Hayes. Hey, what's up, Hayes? If you're watching this, it's really fun.
At the very bottom.
Look this line. This is fun.
Yeah, thank you.
Hi, Scotty.
Hi.
All right.
Hi, Scotty. I wish my parents would just. Can I go take a job real quick? Yeah. Yeah. Sorry.
All right, so the question was about the directrix.
Yeah.
The directrix is P units from your vertex. So since our P is 2, we went down 2 for our directrix, and the focus would be P units above, so we went up 2 for our focus. All right, now let's see if this makes sense. The other way we learned how to graph it. Does this make sense to us? Now, this is 1/8. So that would tell us we would multiply our moves by 1/8. So if I went over 1, 2, 3, 4, normally we do 4 squared is 16. What is 1/8 of 16? Do you see this is over 4 and up 2?
Yeah.
So could we graph the old way? Yeah. Is this a nice shortcut?
Yeah.
Oh yeah.
Yeah.
It's a real nice shortcut. So let's take a look at one more here. Y equals 1/2 x plus 2 squared. Where is the vertex?
2 zeros. Negative 2.
Negative 2, 0.
Negative 2.
So that's the first thing we will plot on our axis. A point at negative 2, that's not what I meant to do. Negative 2, 0. So everybody go ahead and plot that while I'm working on getting mine drawn. Okay, the next thing we have to do is find our P. So 1 over 4P is equal to our A. So does everybody see that P has to be 1/2? If not, you can cross multiply and solve. Do we see that now?
Mm-hmm.
So from this point, we'll go up 1/2 and down 1/2. Which one is the focus and which one is the directrix?
Focus is up top and directions
above and the directrix is down below. The focus is always inside the parabola, and we know this one opens up because it's positive. Okay? So we would draw in this as our focus. Alright, so since we know that P is a half, we double that, which tells us from the focus we would go left and right 1 full unit and draw in our parabola. Now, does this make sense as to the way we used to graph it?
Yes.
Yep, because we multiplied our moves by half. Normal moves are 1, 1, 2, 4. If we multiply them by half, do you see from the vertex, I went over 1, up a half, over 2, up 2.
Still confused between like the whole A and then the 1/4. Like,
Yeah.
it doesn't click for me how we find the P.
Yeah.
This is how do we find it? I just wasn't showing you. You could
Okay.
cross multiply here. If you cross multiply, you get 2 equals 4P. So 2 over 4
Oh,
equals
okay.
P. So P equals 1/2.
Okay, that makes
So
more sense.
algebraically, that's how you
That
do
makes
it.
so much more sense.
Okay, good.
I'm so confused.
All right. Okay. Here's the last one we're going to do today. Y equals -2 times x plus 3 squared minus 1. Where's our vertex?
-3, -1.
-3, -1. Okay, how is this one going to open, guys? Up or down?
Down.
It's going to open down. So I know my focus is going to be above this point, and my, directed is above, the focus is below. Alright, so we say -2 equals 1/4P. So if you want to cross multiply and solve, this is how you do it. So you get -8P equals 1, so P equals -1/8. What does the negative tell us? Down. So, we would go up
1/8.
1/8. That's going to be a little difficult to draw. And up 1/8 is where our directrix is, so it's really close to our point. Our focus is down 1/8, really close to our point. And what would we do from this to find out how far to go? Multiply it by 2, double it, and I'd go over 1/4 in either direction, so this one's fairly skinny. Okay, now, do you see I went over 1, down 2? Do you see that's what it turned into? By doing this, and do you see that's -2, which would multiply my moves by -2? Alright, so you have 2 ways of doing it. This way is harder on this problem, isn't it? This way, multiplying the moves by -2 is easier. So you pick whichever method is easier to graph it. On the graphs, I will want to see the directrix and the focus though. Alright, let's go back to our graphic organizer here. Now, this was our definition, the set of coplanar points whose distance from a fixed point is equal to the distance from a fixed line. Ours said the same thing, just use different words. Alright, the vertex is going to be HK. The focus, what did we do to find focus? We added P to K, didn't we? What did we do to find the directrix? We subtracted P from K.
Is it always going to be add for focus and subtract because the negative changes it?
Mhm.
Okay.
Okay, so this is pointing to our focus, and for us, our focus is HK plus P. And this one is pointing to the directrix. And for us, it's a horizontal line, so it's Y equals, and this is K minus the P. So this distance right here is our P. And from the focus, you go over 2P on either side to get these points. That's right. how we do it.
Hey, Miss Willoughby, how do you get those points that you just put little dots on?
These are 2 times P distance from the focus. So what we did over here is our focus was here, P was 2, so we went over 2 times P, which is 2 times 2, or 4 units.
Okay.
And we do that on either side every time. Okay, now tomorrow we're going to add in the parabolas that open left and right. So this is our focus still, this is our directrix now. Our directrix is now a vertical line. How does a vertical line, the equation for a vertical line start? X equals. Now, do you think we'll add or subtract to our x value or our y value here? X. So it's going to be x minus the p. This is our focus. So this time, we're going to add and subtract to our x. Yes, certainly.
Why is it H?
H always represents the x value.
Wouldn't it be H at the top?
Yes, it would. Thank you.
That's true.
Sorry. You got me. You got me. You got me.
Is that part of this?
Yeah.
And the directrix is x equals h minus p. There we go. Okay, so that's all we're going to add tomorrow, are the parabolas that open left and right. Any questions?
No.
Okay, everybody tell Hayes goodbye.
Bye.
See ya.
Bye, Scotty.
Peace.
Bye, Scott.
Oh, Scotty too, yep.